cancelled, and the leftover terms are TDS plus VDP. So finally we'll get a value DH equal to TDS plus VDP. So this is my second thermodynamic relation. So first thermodynamic relation was internal energy, that is du equal to TDS minus PdV. Even if equations గుర్తుపెట్టుకోవాలి అలాగా. Next enthalpy equation, that is it's known as second thermodynamic relation, that is dH equal to TDS plus VDP. Next let us go for the other energy. So these are all different types of energy, that is Helmholtz free energy. Just if I take that energy here, A equal to U minus TH, where TS, where A represents Helmholtz. So in the same similar way, if I just differentiate, if I write this expression in a differential form, so I can we will get it as dA equal to du minus, so this TS, it is in the form of UV, so that UV simplification have written like this, so that is minus TDS minus SDT. So here what I am doing, again I am making use of my first equation, internal energy du. So du is equal to nothing but d equal to TDS minus PdV. So I am just substituting this our TDS minus PdV here. So when I just substitute those parameters here, the few of the terms will get cancelled, and we'll get as minus PdV minus SDT. Okay. So finally we'll get the third thermodynamic relation. So what is our first thermodynamic relation? Internal energy du equal to minus TDS, plus TDS minus PdV, and second thermodynamic relation is dH equal to TDS plus VDP, and third thermodynamic relation is dA equal to minus PdV minus SDT. So now let us go for the other energy. So what I'm see, basically we are dealing with different types of energies. That is because we are doing the energy balance. So before doing the energy balance, we need to study what are the different types of energies are. So one is internal energy, okay, and other is enthalpy, which is one more energy, and other is Helmholtz free energy, and other is Gibbs free energy. So this is Gibbs energy. So the Gibbs energy, G stands for Gibbs energy. It can be expressed as H minus Ts. So if I just write this expression in a differential form, why I'm writing this differential form? Because see, this G minus HTS is nothing but the expression which are in pure state, And when I use the word differentiate is nothing but some changes are happening in a system. So that is different in a mathematical expression. I do express as dg equal to, so when I just differentiate this expression, so we'll write it as dh, and ts is in the form of uv, so we just write this in the form of mathematical expression uv, right? So here you can see that dg equal to, finally you will get it as dh minus tds minus sdt. So here we can use this, we can still simplify this expression more simple way by using the equation dh. So what we are doing here, I am using that dh expression previously what we got, that is dh equal to tds. This equation I am placing here. So what happens here, the two of the terms will get cancelled, and finally we'll get dg equal to vdp minus sdt. So this is my fourth thermodynamic relation. Is it clear? So finally we'll be getting four thermodynamic relations. So one thermodynamic relation is du equal to tds minus pdv. So this is my first thermodynamic relation. And second is dH equal to TDS plus VDP. This is second thermodynamic relation. And dA equal to minus PdV minus STT. This is third thermodynamic relation. And other is DG, that is Gibbs energy, is the fourth thermodynamic relation. So these four thermodynamic relations you need to be put in your mind. అవి గుర్తుపెట్టుకోవాలి. ఓకే, సో now let us consider second thermodynamic relation. I am taking example. We'll study about one thermodynamic relation. So here I am taking dH equal to TdS plus VdP. So this we are taking. Okay, so first is U, first thermodynamic relation. Second is H, third is A, and fourth is G. Okay, U, H, A, G. So these are the four thermodynamic relations. Now I am taking second thermodynamic relation, that is the enthalpy dH equal to TdS plus VdP. Okay, so the above relation is valid for 1 mole of substance. Suppose if I take for 1 mole of substance, so if we talk like 1 mole of substance is taking place here, then H is nothing but molar enthalpy, S is nothing but molar entropy, V is nothing but molar volume. So in terms of moles, if you just write that expression, so what happens, it can be written as in terms of this. So this equation is in terms of moles, where N stands for number of moles. You can see this, right? So here we can if you just see with the proper concentration about this equation, here all the extensive properties are H, S, V, that is molar enthalpy, molar entropy, molar volume. See, these are all extensive properties which are being multiplied by N. Okay, these are being multiplied by N, H, S and V. Okay, so means you just మీరు పాయింట్స్ గుర్తుపెట్టుకోవాలి. ఎందుకంటే see, because always the extensive properties can be multiplied by number of moles, and intensive properties, if you just see T and P, if you just see T and P, these are same whether 1 mole or n mole are present, means here these properties are not changing. ఇప్పుడు మనం ఇక్కడ ఈక్వేషన్ here you are writing as D of NH. I am not writing as D of NT. If I write D of NT, that is nothing but change in property of the temperature is taking place. Okay, so that's the reason here the intensive properties will not change, will remain as it is, though any n moles of are being taken place or adding. Okay, so this concept, what are these properties are, this relation is there. This applies to all thermodynamic relations. All thermodynamic means internal energy, entropy, internal energy, enthalpy, Helmholtz and Gibbs. So అన్ని all properties, అన్ని thermodynamic relations కి సేమ్ ఇలానే ఉంటాయి. Okay, okay, now we just go on to the other terms, that is partial derivatives and associated relations. Means what are the we'll just study about the partial derivatives, then afterwards how these relations, derivatives are being used with the other relations. So before going to that, first we should know one is a state function is an exact differential. I am saying that a state function. So what is a state function first of all? Okay, so a state function is an exact differential. So what is first of all state function? That is the first question. And what do you mean by exact differential? Exact differential means what? You have studied in mathematics. So that's what. And what it relates, what the exact differential reflects. Okay, these are the questions for this statement. Okay, you can have the other questions also, because but I got this type of questions when I was putting this statement, that here the statement is a state function is an exact differential. The author has said that, he has defined that whatever the state function is there, that is an exact differential. Okay, exact differential means LHS in the properties will be equal to the RHS properties. Same, it should be in a balanced way. That is nothing but a state function. Okay, that characterizes the state function they are saying. Okay, so if let us take homogeneous substances. Homogeneous substance means one phase. So let us take intensive thermodynamic properties. If I'm taking intensive thermodynamic properties which are having two properties, so hence two properties I am taking which are completely understands the state of a homogeneous substance. Two properties I am taking. So example, let us take two independent properties or variables. You can say in mathematical expression you can say you speak as variables, whereas in thermodynamics or in engineering you just use it as properties. That's it. So because here you can see z is a function of x comma y. Okay. This is a mathematical expression, but when I just study about the engineering concept, then I just represent as s equal to t comma v, means my entropy is a function of t and v. Okay, here z is a function of x and y. So here I am taking two independent variables, that is x and y. See, if you just see this expression, z is a function of x comma y, is nothing but what it represents means z, it is a dependent, it depends on x and y, but x and y, it doesn't depends on the z, because the z properties will change in what way the behavior of the x and y are doing. X is having its own properties, y is having its own properties. They are independent. Okay. But when these combine and when they start behaving in a different way, the whatever this z person is there, that's properties changes. Right? So let us take this example, mathematical expression. Just please note down this expression on your paper. Z is a function of x comma y, because we are going to just do this mathematical expression. Because if you just see, just you will get a sleep, you will not understand. So I'm just writing this. You may know this differential equation. So dz equal to, I'm just writing in a differential form, the derivative form, that is dou z by dou x with y dx plus dou z by dou s with x dy. So I think this expression you know very well, because in mathematics we have just written this expression. Okay. So if I just see this equation says in this I am taking this dou z by dou x as m. This term I am taking as m. Sorry. And this dou z by dou y term I am taking as n. So if we can see that from the above equations, dou m by dou y, I'm just writing in terms of m and n. See, previously it was in terms of z. Okay, I'm just see if I'm just changing this expression. So here we can see that dou m by dou y with x